Natural resource. Introduction. Natural resources like water, soil, forests, flora, fauna, etc. The pollution of natural resources as a result of human activities. Natural resources are present in abundance. Explanation. Case 1. Situation in two villages, Vanaparthi and Vadicherla of Warangal district. A survey was conducted in two villages, Vanaparthi and Vidicherla of Warangal district of Telangana region. The first with no scarcity and the second with scarce groundwater. Detailed information regarding various socio-economic aspects was collected using a detailed questionnaire from a sample of 25 households owning wells. Basic features of villages Vanaparthi and Vadicherla are almost similar in terms of occupational pattern, cropping pattern, infrastructure and social service. In both the villages, small farmers are in majority. Vanaparthi has the higher average household income. The main livelihood activity in these villages is cultivated and the primary source of irrigation as well. Vanaparthi has a higher proportion of its area under irrigation. The cropping pattern influence average household income in these villages differs substantially. Though rain has not been constant for a few years, farmers in the villages prefer growing paddy. Table 1. Area under irrigation. Village. Total area. Acres. Percentage area irrigated. Number of wells. Sample size. Vanaparthi 3791. 25%. 155. 25. Vadicherla 2970. 15%. 175. 25. The change in area under cultivation, percentage change in number of wells, and cropping pattern in 5 years. The population in the villages has also gone up in a period of 5 years by nearly 10%. Table 2. Status after 5 years. Village. Percentage change in area under irrigation. Percentage decline in number of wells. Percentage change in area under crops. Paddy, cotton, gingerly, all crops. Vanaparthi -14, -39, K -17, R -17, 163, 86, K 11, R -17. Vadicherla -30, -68, K -22, R -50, 27, 138, -5, -50. Therefore, K stands for Kharif while R stands for Rabi. Negative values indicate loss or decline, while positive ones show gain or rain. The open duct wells were converted into bore wells and could reach greater depths of groundwater zones and would also reduce loss of water by surface evaporation. Most of the open wells have dried up and water tables have gone down substantially during the last 5 years. During this time, 85% of the wells, mostly open, have dried up in Vadicherla, while 45% of the wells dried up in Vanaparthi. Water is usually pumped out of wells and bore wells using electricity. Farmers with small land holders or small farmers tend to spend more money per well in terms of installation of pump set and pipeline connection to farms, as well as running costs towards maintenance, electric charges, etc. On per acre basis, both capital and running costs are the lowest in Vanaparthi and highest in Vadicherla. Table 3. Annual expenditure on well irrigation for small and large farmers. That is, for 2002, village, type of farmer, depth of bore well in feet, percentage area irrigated per well, Kharif, Rabi, total cost of well irrigation per acre per year in rupees. Vanaparthi, large 130 to 200, Kharif 2.50, Rabi 1.24, 25,000 to 70,000. Small 110 to 180, 2.00, 1.13, 25,000 to 65,000. Vadicherla, large 90 to 300, 1.53, 0.87, 22,000 to 50,000. Small 60 to 200, 0.99, 0.46, 20,000 to 45,000. Table 4. Income on crops. Village, type of farmer, net income per acre in rupees. Paddy, Kharif, paddy, Rabi, cotton, gingerly. Total income per acre year in rupees. Vanaparthi, large 8,200, 8,700, 4,900, 3,300. Total 25,100. Small 7,046, 8,490, 10,889, 3,110. Total 29,535. Vadicherla, large 10,698, 5,970, 4,000, 3,595. Total 24,263. Small 9,128, 7,380, 3,031, 2,650. Total 22,189. A project of the Center for World Solidarity that addresses sustainability of groundwater intervened to help in recharging wells that were drying up in the villages. They encouraged more water sharing among farmers. Farmers also motivated to use irrigation techniques like drip irrigation, sprinklers, etc. Construction of soak pits to tap rainwater optimally was carried out as community efforts. Soak pits helped in recharging dried up bore wells, dikes or barriers nearly 30 cm thick of thick cement or stone cement barrier extending down to the compact bedrock with mud or clay filling built in underground streams to tap groundwater optimally. Water for all. Out of all the water on earth, salt water in ocean, seas, and saline groundwater make up about 97% of it. Only 2.5 to 2.75% is fresh water, including 1.75 to 2% frozen in glaciers, ice, and snow, that is, nearly two-thirds of the availability fresh water. 0.7 to 0.8% as fresh groundwater and soil moisture, and less than 0.01% of it as surface water in lakes, swamps, and rivers. Though it is a large portion of the whole, if used judiciously, lasts for a long time. Case 2. A study of Potapalli village, an example of water management effort. First, dry and areas were more extensive than irrigated land. Literacy was low. Labor was scarce. More fertilizers or pesticides used on small farms. Crop yields low. There was not even a single water harvesting structure in the village. Interventions to enhance productivity and income. International Crop Research Institute for Semi-Arid Tropic. Educated villages by large and provided technical support for cost-efficient water storage and soil conservation structure. The measures community as well as individual farmer take. These help to restore some resources and conserve others so that they may never be depleted. Community-based intervention. 14 water storage structures with water storage capacity of 300 to 2000 meters cube constructed. 60 mini pre-collision pits and field bunding on 38 hectares completed. 28 dry open wells near Nalla or the Lakshmi Canal recharged by building ducts or barriers in the Nalla and retaining the runoff rainwater in it. A users group was formed for each water storage structure, and the water collected in the storage structures was exclusively used for recharging the groundwater to the dried well. Farmer-based interventions. Farmer-based soil and water conservation measures implemented in individual fields, both bed, furrow, landform, and counter planting. These are all useful to conserve soil and water, fertilizer application, and weeding options. Field bunding of 38 hectares around boundaries in rectangular or in contour to conserve rainwater. Planting Grillicidra on field ones to strengthen them and make the soil nitrogen rich. Farmers encouraged to use water resource jointly and irrigate land using micro-irrigation technique. Farmers obtained 250 kg more pigeon pea and 50 kg more maize per hectare using more bed furrows and micro-irrigation technique. Drip irrigation can reduce water consumption by 70%, but unfortunately only 2% of cultivable and around the world is irrigated in this manner. Wasteland development and tree plantation. Saplings of useful species planted along the roads, field bunks and nalla, counter trenches at 10-meter intervals with a 0.3 meter height of bund laid out. Custard apple plantation along with other useful species in trenches and Glyricidra Samplings on bun was undertaken by the farmers. 2,500 fruit trees and tea plants planted. According to the survey conducted in the year 2004, total amount of water available in AP is 3,814,000 million cubic feet. Total amount utilized 2,300 TMC, of which irrigation is 2,268 TMC, domestic use 21 TMC, industries 10 TMC, power generation 1 TMC. Amount required for utilization by 2025 is 3,989 TMC, of which 3,814 TMC is for irrigation, 122 TMC for domestic use, 51 TMC for industries, and 2 TMC is for power generation. Source of irrigation water in AP. The major consumption of water is in the farming sector. In spite of some major rivers like Godavari and Krishna, the major source of irrigation is groundwater. According to United Nations Development Program, water resource in an area where annual water supply drops below 1,700 meters cube per person is becoming scarce. The Food and Agriculture Organization of the United Nations has predicted that by 2025, 1.8 billion people will be living in countries or regions with absolute water scarcity. Activity 1. Natural resources around Earth. The Earth's natural resources include air, water, soil, minerals, fluid, plants, and animals. Conservation is the practice of caring for these resources so all living things can benefit from them and in the future. All the things to survive, such as food, water, air, and shelter, come from natural resources. Some of these resources can be replaced after they are used and are called renewable resources. Other resources, such as fossil fuels, can't be replaced at all. Once they are used up, they are gone forever. This is because it takes a long time for their formation, while their consumption occurs very quickly. These are non-renewable resources. People often waste natural resources. Animals are overhunted. Forests are cleared, exposing land to wind and water damage. Fertile soil is exhausted and lost to erosion because of poor farming practice. Fuel supplies are depleted. Water and air are polluted. If resources are carelessly managed, many will be used up. If used wisely and efficiently, renewable resources will last much longer. Through conservation, people can reduce waste and manage natural resources wisely. Water use restrictions are in place in many regions of the world. In Australia, in response to chlorine storage resulting from drought, restrictions are imposed on activities like watering lawns by using sprinkler system, washing vehicles, using hose pipes to clean paved areas, and refilling swimming pools. The population of human beings has grown enormously in the past 2 centuries. Billions of people use up resources quickly as they eat food, build houses, produce goods, and burn fuel for transportation and electricity. Their continuation of life as depend on the careful use of natural resources. The need to conserve resources often conflict with other needs. A forest area may be a good place to put a farm. A timber company may want to harvest the area's trees for construction material. Development and conservation can coexist in harmony. The environment used in ways that ensure we have resource for the future. It is called sustainable development. There are many different resources need to manage and conserve and main order to live sustainably. Forest, an important renewable resource. Every continent except Antarctica has forests, which are rich habitat for plants and animals. Forests serve as a lung for the world and a bed of nutrients for new life to prosper. They provide us innumerable products, and in an urge to extract them, we indiscriminately destroy them. People clear forests to use the wood or to make a way for farming or development. Each year, the earth loses about 36 million acres of forest to deforestation, an area about half the size of our state. Deforestation destroys wildlife habitat and increases soil erosion. It also releases greenhouse gases into the atmosphere, contributing to global warming. Deforestation accounts for 15% of the world's greenhouse gas emissions. Deforestation also harms the people rely on forests for their survival. Hunting and gathering, harvesting forest products, or using the timber for firewood. Sustainable forestry practices are critical for ensuring resources into the future. They protesting against the king's order to collect wood for the construction of his palace and defending the pledge of peaceful coexistence taken by them as a Bishnoi. It is a set of 29 rules to conserve nature's resources that every Bishnoi vows to protect. Some sustainable forestry methods include using low-impact logging practices, harvesting with natural regeneration, and avoiding certain logging techniques, such as removing all the high-value trees or all the largest trees from a forest. Trees can also be conserved if consumers recycle. People in China and Mexico, example, reuse much of their wash paper, including writing paper, wrapping paper, and cardboard. The world's paper recycled, much of the worldwide demand for new paper would be fulfilled, saving many of the Earth's trees. We can also replace some wood products with alternatives like bamboo. It is a type of grass. Soil. Soil is vital to food production. High quality soil to grow the crops that we need. Soil is also important to plants that grow in the wild. Many other types of conservation effects, such as plant conservation and animal conservation, depend on soil conservation. Poor farming methods, such as repeatedly planting the same type of crop in the same place, deplete nutrients in the soil. Soil erosion by water and wind raises farmers' bog up and downhill. One soil conservation method is called counter-strip cropping. Several crops such as corn, wheat, and clover are planted in alternating strips across a slope or across the path of the prevailing wind. Different crops with different root systems and leaves help to prevent soil erosion. The practice of removing individual plants or small group of plant leaves other plant standing to anchor the soil is called selective harvesting. Biodiversity. Biodiversity is the variety of living things that populate the earth. The product and the benefit get from nature rely on biodiversity, a rich mixture of living things to provide food, building materials and machines, as well as to maintain a clean and healthy landscape. A species becomes extinct, it is lost to the world forever. Scientists estimate that the current rate of extinction is 1,000 times the natural rate. So, hunting, pollution, habitat destruction, people are spreading out the loss of biodiversity at an alarming rate. Scientists discover thousands of new species every year. Example, after looking at just 19 trees in Panama, scientists found 1,200 different species of beetle, 80% of them to science at the time. Based on various estimates of the number of species on Earth, we could be losing anywhere from 200 to 1 lakh species each year. Protect the biodiversity to ensure plentiful and varied food sources. Biodiversity is important for more than just food. For instance, we have 50,000 to 70,000 plant species for medicine worldwide. Activity 2. Some governments have established parks and reserves to protect wildlife and their habitat. They are also working to abolish hunting and fishing practice that may cause extinction of some species. Fossil fuels. Fossil fuels produced from the remains of ancient plants and animals. They include coal, petroleum, that is oil, and natural gas. Apart from its use in vehicles, many of the products we use today are made from petroleum. These include plastic, synthetic rubber, fibers like neon, medicine, cosmetic, wax, cleaning products, medical devices, etc. We need to conserve fossil fuels so we don't run out of them. There are other good reasons: the pollution caused by them when burnt. To limit our fossil fuel use, scientists are exploring alternatives to fossil fuel. They are trying to produce renewable biofuels to power cars and trucks. They have successfully produced electricity using the sun, wind, water, etc. Everyone can help conserve fossil fuels by using them carefully. Turn off lights and other electronics when you are not using them. Purchase energy-efficient appliances, walk, ride a bicycle, and use public transportation. Mineral. Earth's supply of raw material resources is in danger. Many mineral deposits that have been located and mapped have been depleted. The ores for minerals like aluminium and iron become harder to find and extract. Their prices go up. This makes tools and machinery more expensive to purchase and operate. Many mining methods such as mountaintop removal mining devastate the environment. They destroy soil, plant and animal habitat. Many mining methods also pollute water and air as toxic chemicals leak into the surrounding ecosystem. Activity 3. Nowadays, people are revolt against mining. Less wasteful mining methods and the recycling